Hi everyone! In the previous video, we reached the set goal 100 shader effects, which are available in the product called Godot Shader Pack, linked in the description of this video. Of course, I plan to keep creating shaders and gradually add them to the pack, at least as long as I have inspiration. This time, we'll make another transition effect, and as you can see, it simulates something like a pixelated change of the background image. Let's take a look at how easily we can program a similar effect. And because this is a transition, we will once again need two background images, which I'll again borrow from our game. So I'll create the usual 2D scene with all the elements that belong in it. Okay, right-clicking the scenes folder, create a new scene, 2D scene, and let's call it noise transition. Okay, and as I said, I will drag the background image into the usual one found in JPEG. Okay, so the sprite 2D node was automatically created, and let's go to the inspector and fix it as usual. So offset centered should be disabled and transform position reset to 0, 0. Okay, scrolling down to the material section, let's create a new shader material and click it and create a new shader, which is called Noise Transition GD Shader, type shader, mode canvas item, and as always, I will put it to the shaders folder. Shaders, create, and click again to open it in the shader editor. Let's expand the window a little bit. And as always, I'll delete everything from the generated code that we won't need, leaving only the fragment function, deleting vertex, deleting white, and Ctrl S to save. Okay, so we can start writing the code, and this time I'll do it in the natural order. First, the uniform parameters, then the helper functions, and finally the main fragment function, this one. We can afford to do it this way because the algorithm is simple, so there is no risk of getting lost between the individual layers of the code. And as usual, I'll comment on every step. So let's begin with the uniform parameters. As we saw at the beginning of the video, we'll be performing a transition from one image to another, so the first parameter will define the target image. Okay, so uniform sampler 2D, and let's call it target, and I will give it this hint. So I used the hint default black parameter in case we only needed a transition to a black screen. In that case, we would leave this target parameter empty, but we are definitely going to insert an image there, so let's do it right away. Okay, so in the inspector, I'll expand shader parameters, and there is the target parameter, which is currently empty, and let's drag the usual JPEG into it. Okay, cool. The second parameter in the inspector, the second parameter in the code will define the number of squares that will form our pixelated effect. I say number, but in reality, it refers only to the number of squares in the vertical direction, that is, along the y-axis. So it would be uniform float squares with a hint range and initial value. Let's start with 20 squares along the y-axis, and of course the range should go from 1 to, for instance, 100, and the step should be 1. Okay, and finally, we need to know the current phase of the transition so that we can control this effect from a script in the game. Uniform float phase with another hint range, and it starts at 0. Okay, and it usually goes from 0 to 1, but I think that in this case we will need a longer range because the effect has some specifics which require a longer transition phase. We'll get to that. Okay, so that's all for the parameters. As you surely noticed, the transition effect shows some signs of randomness in the placement of individual squares, which we achieve using a typical pseudorandom function. I use it very frequently, so once again, I'll save time and simply insert it in the code. And I already have it in the clipboard, so all I have to do is just to simply press Ctrl V to paste the function. Just as a reminder, the name hash12 means that the function returns a one-dimensional float value based on a two-dimensional input parameter vector2. So we have everything prepared and we can move on to the fragment function. From previous tutorials, you may remember that when we create a symmetrical effect, we often shift the origin of the coordinates to the center. This time, that's not necessary, so we'll work with the UV coordinates of the current pixel exactly as they are. So let's do this. Vec2 UV is simply UV. Okay, however, we want the effect to be composed of squares, regardless of the dimensions of the element to which our shader is applied. We've solved this problem many times already. So in the next lines, we'll recalculate the aspect ratio based on the texel size of our image, which means vec2 resolution is 1 divided by texture pixel size, the texel size, and now the recalculation. So UVX is multiplied by resolution X divided by resolution Y, usual stuff. Excellent. And now our effect will be based on a simple algorithm. We divide the screen into a square grid, and for each square we determine whether it should display pixels from the original image or the target image. The step function will help us with this because it returns a value of 0 or 1 depending on a threshold. But we'll get to that soon. First, we need to transform the UV coordinates to represent the square division. So it would be UV is floor UV times squares divided by squares. Okay, as you might remember from previous tutorials, we usually use the floor function to make the division of the screen and use a grid. So it's here in the same way. Next, we need the value of the hash12 function for the current UV coordinates. So let's call it noise. Float noise is hash12 of UV. Okay, and now we want the effect to move from the left edge to the right, which we'll achieve by including the x coordinate of the current pixel in the calculation. I'll call the value edge because we'll use it as the parameter of the same name in the upcoming step function. So we'll calculate it like this. Float edge is face minus UVX minus noise. And now, using the step function, we obtain the weight parameter for the final mix of two images in the current square. Float weight is step edge and 1. Okay, so this function returns 0 if the second parameter, that is this 1, is smaller than the edge value. Otherwise, it returns 1. And now we can assign the final color of the current pixel. As I said, we'll use the mix function, which performs a linear interpolation between two values based on the weight coefficient. And because that coefficient will take only the values of 0 or 1, we'll get the pixel from either the first or the second texture, like this. Color, the output is, as I said, mix, and now texture function of our background image, texture and UV in capital letters, then texture of the second image, which is target, and again UV, the original one, and finally the weight value. Okay, so as we can see now, let me just show more of the image. As we can see, we've achieved exactly the opposite effect. When the face parameter in the inspector is 0, we display the second image. And as the face increases like this, yeah, it changes to the first. So we'll fix this with a small adjustment to the weight variable. Let's get back to the script, and instead of step, we will do this 1 minus step. Okay, and now let's try it again. Yeah, seems to be correct. Okay, so I guess we are done. We can try changing the size of the squares based on the squares parameter. So now we have 20, and what if I change it to 88? Okay, it seems like a completely different effect. I mean, it's not different, but it looks a bit different. Or 100, or if I go back to, for instance, 2, maybe it's too low, 5. Okay, this could be an interesting transition as well. Let's get back to 20. Very well, one last thing. Some people might want a slightly smoother transition and actually mix the fragments of both images. This can be achieved by allowing the weight variable, this one, to take not only the values of 0 and 1, but also other values in between. To achieve this, we use, instead of step, the clamp function, which will ensure that this value stays within the interval 0 to 1. So it would look like this. I will comment out this line and write a new one. Float weight is clamp of edge value, and the interval is from 0 to 1. Okay, let's try it out. Let's get back to 0, and now if I'm moving, we can see the transition is much smoother, and the squares are composed of both images. Very well. We can also try what happens if we skip the clamp limitation. Then the mix function will work with values outside the 0 to 1 range, which will result in increased exposure of the pixels for values less than 0 or greater than 1. Let's try it. So instead of clamp, this we'll use only the edge. And yeah, here we can see how it's overexposed. Now it looks almost normal, and it's overexposed again. I think it's better to stay within the 0 to 1 interval, unless of course our goal is to enhance the image in the way we just saw. So, and I also think it's better to return to the original version with the step function. So let's just revert these steps, and yeah, this should be it. Because that's what this tutorial is primarily about. Anyway, it doesn't hurt to have alternative solutions available. Thank you so much for watching. I'd say there can never be too many simple effects like this, and we can certainly use them in many game projects. Besides, thanks to their simplicity, they can inspire many game developers to adjust them according to their needs. I will, of course, continue making more tutorials, although they won't always be about shaders. Anyway, take care, best luck with your own game projects, and I'll see you in the next video.